Welcome to the IpX True North podcast, where we connect people, processes, and tools. This is part 2 between Arnaud Hubaux, the Senior Program Manager for ASML, and Maxime Gravel, the Director of Model-Based Enterprise for IpX. In this part, they will be discussing data management for AI, warehouse big data, and CM.
I know a few years back at the IpX, you had brought about, should variance management be part of configuration management? I still remember that question. So I want to turn around this one, and it's a very interesting, as ASML, the design group and software group are making change to their machine. Do you foresee a change in how impact analysis, traditional impact analysis is done? And do you see potentially in the future some sort of a CM branch of machine learning or AI being integrated with that product? It's an interesting question. What's your opinion about that? And what do you think? What do you think about this?
Yeah, I think yes. The short answer, yes. I believe there should be dedicated solutions to support AI, because AI has this property that it is highly dependent on data. And data typically is something you don't control. When you do regular software, you know your software will have a database, like all software application. And the database in the software, the data in the database, when you release your software, it's not a problem. I mean, you qualify your software so that the data structures are correct, the queries will always run. If the data is missing, it doesn't crash. Those kind of things you can put in your standard process. With AI, you actually move some of the behavior of your system. You move it to the location where it is deployed. It means that your impact analysis, your qualification process must basically stretch beyond the walls of the company into the environment where it will be running. And of course, you cannot do it for all the places where it will be deployed. This would just be way too big. In the case of ASML, we are lucky that there actually are few companies who actually produce chips, so the number of customers is limited. But if you release applications for the masses, like on edge devices where you will send hundreds of thousands of units, you can't do impact analysis on every single location. So it means that in your impact analysis process, you must do until the boundary of your company, but also make sure that the design themselves can track their own baseline, can backtrack in the baseline and reverse changes if required, qualify the solutions before even making it active for the end users. Like if you have a self-driving car, you never know what can happen. So you want the car to be able to probably go back if the change is impairing the behavior, or maybe the car doesn't stop anymore. So with AI, we are really dependent on the data we don't control. So the process was included. And where I do see a gap today, if you look at AI, there is, of course, a huge community around it. And you will find now a lot of focus on the concept of MLOps. So how do you operationalize machine learning model? And it's coupled to DevOps cycle, which is just for regular software engineering. And those models focus very much on the technical aspects of it. So from a software perspective, what are the tools that you need to do it, to do proper code reviews, development cycles, and container orchestrations? All those solutions are there. But what I still miss is this overall enterprise level framework that not only looks into the tools you need to do good machine learning engineering, but really look at the complete life cycle of the change, like you have in CM2. And I think stretching that part would be extremely valuable.
Yeah, thank you, Arnaud. What resonate with me is I think it just clicked in my head is once we do the impact analysis within our wall now, we still got to understand the machine learning part, which is somehow part of the machine, if you wish, right? So you got to bring that impact analysis and understand that side of the house. This is something totally. This brings a totally different flavor of what end-to-end and enterprise, enterprise-wide impact analysis mean. Now you got to look at the personality of your machine. So But a lot of
Yeah.
times, Arnaud, I think there's you talk about canary testing. So a lot of times there's time where they will do some, they will keep the old ML algorithm, right, before switching to the new one, right, as a precaution.
Yes.
And I don't know how, I don't know, it's an interesting question, but are you aware of any case where the production was shut down because of ML at this point today, or not that you know of, or is it
Not that I know
potential?
of.
Okay.
Yeah. And this is why I think you see, I would say, the semiconductor industry, but overall, I think all manufacturing industries, I see some reluctance to really adopt and deploy ML for critical tasks that could really put the production process down, because there is still this part of unpredictability, or at least perceived unpredictability. So you see that it's being used in pockets for very niche use cases where it is extremely efficient. Like I said, defect analysis, some local optimizations where machine learning is perfectly suited for those use cases. But when it comes to really having a self-driving product line,
Yes.
that would be the dream of everyone building a fully automated product line. But that is also a very big risk, and that's the part where I think we still have to mature. And this is where I was talking that it's not only about the algorithms themselves, because I think they are okay, but it's more the overall process and governance you put around it to prevent issues like safety, for instance, or damaging equipment. So how do you build in your system those safety mechanisms so that even if the AI goes a bit crazy, you don't risk causing extremely large financial
And if you back to I think the car industry, the self-driving car, one of the challenges, all the environment, right? There's so many things that can happen in the environment that could trigger unwanted response from the machine learning. This is what we hear with the car, right? There's a shadow, or there's some wind and a branch start to flop. So is this possible that a car or sees it as an obstacle and push the brake and cause some concern? Heavy rain, right? If you think about all kinds of stuff that are, so I assume it's the same principle, right? Same concept with the machine learning for production, right? It's still, this is where I feel maybe we still need to gather more data, understand all the different parameters before we let fully automated, as you mentioned, Arnaud, without human intervention, production line, which might be the dream, right? I don't know if it's going to happen before the car, or that's an interesting question. Which one will come first?
Yes,
That's
indeed.
a good. Thank you, Arnaud. So this is very interesting. The topics you brought, it just I me. And in your team today, Arnaud, you are the senior program manager for AI. Do you have a group that are dedicated to CM in your team today, or not today, or you're leveraging the rest of the company? How does that work? Oh, smart.
So
What's
there
your
is no
view? Yeah.
group. There is no group dedicated to CM for AI. There is the normal group in the company doing CM for our machines.
Yes.
AI is still, I would say, a growing competence. So we have people who are extremely good with all the machine learning model, the data science. And what is interesting to see that as we mature in our journey towards the adoption and the industrialization of AI, the topics I mentioned become very visible, because we see that we're maturing from a phase where we just have to say, okay, we can be accurate, which is basically step number one when you do machine learning. You want your model to accurately predict what it is supposed to predict.
Yes.
And once you're there, people start to get excited and they say, okay, let's use it in production because it seems to bring value. But the question then is, okay, then I will deploy this model and I have to sustain it for the next 5 to 10 years. And then what? And then all those questions start to pop up on the table. So you have to include in your design process the special qualification steps for the improvement. If you change the data structure, if you change a physical model, if you change the machine learning model, if you see variations in your data sets. So how do you make sure that there are very precise action plans for the customer support engineers around the world to execute, to make sure they can keep the machine performing the way it should. And the second thing is you also realize that those systems, they process so much data with such diversity in the data sets and at locations that we don't control, that we can't even remotely access. You have to build in your systems mechanisms so that they can do the basic maintenance themselves. So maintaining their own baseline, we discussed it already. Also be able to do data healing if they see that data packages are corrupted. They have to know if they should be just ignoring the package coming in, or if it's just a few fields that are missing, for instance. You want to make sure that they can fill them with a value which is not the value as it should have been, but at least something that doesn't prevent it from operating correctly. And maybe you want to exclude this data package from a training set it will use in a daily training loop. So we have to put all kinds of mechanisms in place to first mature the organization in being able to support those machine learning model. And part of the applications themselves provide mechanisms so that they can do their basic autonomous monitoring to reduce the load on engineers and human.
So from what I understand from what you say, Arnaud, the first thing though is to have a good control of your physics model, right? AI and machine learning just optimize, they build and enhance this physics model. So the first step is to have a good grasp of the physics model and understand from a change management, I would say, if you do some change, you cannot miss an impact to the physics model as a minimum, right? That's the step
Correct,
one.
yes.
So that's the first thing what I would hear to start is make sure that there's as part of your impact analysis, there's a true understanding of the physics model. Once this is done, what you say is there's another layer of maintenance and baseline, but this one is going more and more being automated or embedded within the machine learning algorithm themselves and the AI.
Yes.
Is this a fairly good understanding?
Exactly. And what is interesting, and I'm very curious to see how ML solution will develop in the future, because the physics is typically the core of your business. So this is the value that you add that no one else can. The machine
Yes.
learning part, everyone can use, because no one is really doing in their product research in AI. They typically reuse existing models and algorithms. They do tweak them a bit, but fundamentally everyone has access to those. So it is really, I think, becoming a commodity, and you should treat it as such. It should not be a core differentiator because everyone has access to this technology now. So I really hope that those techniques during autonomous maintenance and support for drift and data corruptions, that should all become standard parts of the offerings you see by either cloud vendors, for instance, or just open source libraries that everyone is using, so that businesses can focus really on their core values, which in the case of ASML is physics models, but for other companies would be the labels of the images they want to classify, those kind of things.
That's so. I never thought like that. So what you're saying is we're at the point today where machine learning algorithm are commodities already. This is very
I think they are turning into commodities, yes.
Wow,
And then they should. It's like if you're a software company, no one is writing a compiler that is turning the code that the developers are writing into a binary that can be executed. No one is doing it anymore today, unless you have very specific embedded software to write. No one does it because it is a commodity. Everyone will tell you, I'm just taking it off the shelf. And I think hopefully for ML, it will also go in that direction. Because I think, honestly, building those models is really a craft. And actually, there will just be no capacity on the market to develop them. So you have to reuse off the shelf those models because there would be no business case for companies to start doing it from scratch.
Too much knowledge, and it will take too much. Okay, that's very interesting, Arnaud. I never thought of it this way. So just the last question now, or one more question from your side of the house. If you are, so what you say that AML is becoming commodity. So if you're a product manufacturer and ASML is a very complex machine, you know, it's a very high level complexity and configuration, where would you start if you want to start to implement ML? And also, where would you start with focusing your energy on CM at the same time? I would see that both can grow together. So from a first perspective as a product manufacturer, where would you start? And then we can, second question is, where would CM start also? Where would
Yeah.
you recommend CM starts?
So the start is with the obvious, but the obvious is what most companies doing AI miss is really start from the value that you want to create, from the problem that you want to solve. Because I see too many times people saying, "Oh, I have to apply ML or I have to apply AI." It's like, "Hey, I bought this hammer. Does anyone has a nail? Because I really would like to try it." That's really a typical scenario you see because they read some report from a strategic consulting firm saying, "Hey, there are so many billions that could be made by using AI. I have to do it, otherwise I will be missing something." So I think that's the wrong thinking. I should rather say, I have a frame, I need a nail, and I need a hammer, and AI will be that hammer. So start from the value that you want to create, and it can be value for your own customers in your product, or just savings that you want to execute by just reducing the cost or just improving your time to market. So focus on finding that value.
And just before you keep going, I want to say, because I'm the director of model-based enterprise, when you say with ML or AI, it's the same thing. You hear a lot of companies is, I must have 3D model. I need 3D model. Everybody's using 3D model. Then I want 3D model. So how do I get there? And I would have to say, as just like you, is first let's understand the value. You know, where is the value of using 3D model versus drawing? So very interesting statement. I just wanted to bring that analogy because I hear that from my side on a daily basis, and I'm sure from your side you hear the same thing on a daily basis. I want to do AI. So just very interesting there. So sorry to interrupt, but I just want to bring that analogy. So treat AI, ML, just like the 3D model-based 3D CAD. It's not everybody's got to use it for their own good, for the value for them. So thank you, Arnaud, for that. And with that, please, you can continue answering the question about the next step, or where would you start after that? Oh, you're getting smart, man. All right, so yeah, let's go on the next. That was good. I like this one, Arnaud.
So, and when you have identified the value, the thing is that AI doesn't come for free. There come risks with AI. I mentioned, for instance, explainability is one. Another one is you also might depend a lot on the context where it is deployed. So it means that you might have to invest in making it very robust for those context-specific use cases. So when you deploy AI, and this is also related to CM, it's always about also the benefits of using that AI in a context that you can sustain. It's not just a one-off, okay, I have this data set for this use case that I know brings value to my company. I've been successful, great, now let's deploy it worldwide. It doesn't go like that. So you also need to make sure that you put around the models you're making the proper processes to control changes, to make sure it is sustainable, and not just that you bring along the bright data scientist who knows exactly how to tweak and do hyperparameter tuning on your neural network. No, you also want people who can guard the quality of the data, because in most cases the data quality is the gatekeeper towards a highly performing machine learning model. So, and that is all CM. So really, I think CM has a big role to play in maturing the adoption of AI in a manufacturing environment, because it will put gates, it will put checks in your impact analysis, in the release of the changes, to make sure that you implement the proper qualifications in-house, at customer locations, and throughout the lifetime of the product, which is not something that you see people consider mostly. They are still very much focusing on the short-term benefits of, oh, I want to use AI. If it's accurate enough, then I can deploy, and then we'll figure out later how to deal with it. It's okay if you build small devices, but if you're a whole production line depending on it, that's a completely different ballgame.
So what I hear is it has to be sustainable. So where CM can help is making sure there's processes in place and gates, as you mentioned, to make sure that the AI is sustainable, because I would agree it's like a child, right? I guess a machine learning is like a kid, and that kid's gonna hopefully live a long life, right? And get wiser. So this is very good. And the other thing I think you mentioned is data quality, right? Making
Yeah.
sure that you gotta keep that data quality. And as I understand, as the environment evolves or the physics model evolves, you gotta look at that data also. It may ask you to require with different physics model keep up with that data quality to grow with, I guess, the child, right? The machine learning, the AI, as
Yeah.
the AI grows. So very interesting, Arnaud.
And something that
Very
maybe
good point.
is worth adding as well is that it's also part of the impact analysis and being thorough in it, because AI is very data greedy, which means it's very CPU greedy, memory greedy, storage greedy. So you all see there that companies who start adopting AI, they start small, starts to work. No, they realize that their digital infrastructure is not there to scale. So they start looking, oh,
Um,
I want to go to the cloud, which is another big step, because then they start having issues or concerns about security and IP protection and the cost, and how do I migrate from one environment to the other? What is the
yes.
impact of my way of working? And then when you're there, you also deploy on edge devices. But running a traditional piece of software versus training a model are two very different use cases. So you see that the hardware of the device that you're shipping to your customers, it starts to differ, because you need to provide more maybe GPU or different types of chip architectures that are better suited for machine learning type of use cases. So the impact of adopting
Mm,
ML is extremely far reaching. It really goes even down to the core of your organizational, I would not say culture maybe, but at least structure. Because, for instance, going from doing everything on-prem on small laptops to a journey to the cloud, it triggers all kinds of discussions around ownership, data governance, how do you do
mm.
configuration management on that whole thing. So it really opens Pandora's box. There is a lot to gain, but you have to plan it carefully. It's not just about having an algorithm that has an accuracy of 99%.
Oh, thank you, Arnaud. Yeah, this is a different, yeah, the way it is a new landscape. It is really adding, to me, I see it's adding another dimension, almost another dimension to traditional configuration management, where where there's a brain, right? You got the machine, and then you got to make sure you keep that the brain of the machine.
Yeah,
This is becoming, and all the interaction between the two, as you talked earlier. You can change something physical, and it may impact the machine learning algorithm, and vice versa, right? I'm sure you have case also where you change the algorithm without changing the physics model. I guess the two scenarios can happen,
yes,
or so
exactly.
it can be one without the other. If one change, it probably impacts the other, and every time you got to do canary testing to make sure that you understand. It's hard, from what I gather. It's sometimes hard, or almost that's the nature of ML, to predict sometimes the output of what that machine learning will do, unless you do some sort of qualification or uh, canary testing, if you wish. Does that?
Yeah, exactly. And this is almost a paradox with machine learning. The mathematical foundation is extremely sound, but the behavior is almost empirical. So it really depends on how much data it is seen, on the quality of the data it is seen, on the history of the data it is seen. So that's where the qualification, you always need this, at least as far as I'm concerned, you always need this step where you really run it on real data and see if the behavior is expected for this specific context.
Context. And it doesn't mean that it works for this context, that it may will work the same for a separate context. Like you
Exactly. You can
mentioned, factory one versus factory two could actually impact. So it's very instance specific. It's context specific.
Exactly. You can be a very good driver on dry roads. If I put you on ice, it will be a completely different story. Although it's the same car, the same tires, same driver, but it's a different context. It's exactly the same here.
Yes, actually, Heis, from my background, raised and born in Canada, Arnaud, yes,
Yeah.
I have to say, Heis is slightly, especially if you have a front-wheel drive car.
Yeah.
Back in the
It's
days.
fun, but it's different driving.
Yes. All right, so I just want to say thank you very much, Arnaud, for sharing your time with us today. This was very eye-opening for me. I did every time we talk with you, I learn more. And thank you very much for your time to help us understand how AI and CM can go hand to hand.